Okay, let's go ahead and get started with our third kind of part 3 basics to stoichiometry, going back over just one type of each problem. Let's use those exact same steps that I outlined in the first video and read our question. It says if 25.0 grams of nitrogen monoxide reacts with NH3, how many moles of N2 will be formed? So guys, get rid of all the words and let's just focus in on what is the information that is given. And that is 25.0 grams of NO. So we're going to start by writing that down. 25.0 grams of NO, nitrogen monoxide. The second step was, what units are we trying to get to? Well, we're trying to get to, it asks for how many moles of nitrogen. So I'm looking for moles of nitrogen, which is what I'm going to write over here. Now I've got my beginning and ending units. The next thing I do is draw my T-chart. I've got to get away from grams of nitrogen monoxide. So the very first thing we're going to do is going to go ahead and drop those units down. Okay. So right here, you dropped your units, now what? Well, let's think back to those conversion factors. You have three options. You have the 6.022 times 10 to the 23rd equals 1 mole. Well, why would we use that right now? Because that has to do with atoms and molecules, which this problem has nothing to do with. The second option, was molar mass. Well, let's think about what molar mass represents. Molar mass, we said, took the mass of a substance, and that represented 1 mole. Well, look right here. We're trying to get rid of grams, so the only logical thing to put there would be the molar mass of nitrogen monoxide. And that value, you could hit pause right now and type that in your calculator. If you do that, you would get 30.006 grams. Now think about what that number means. That number represents 1 mole of nitrogen monoxide. Okay, so now we've got grams canceled out, and look where we're at. We're at moles of nitrogen monoxide, and look, we're trying to get 2 moles of N2. So we know we've got to get rid of these units, and the only way to do that is to drop them down. So I drop down moles of nitrogen monoxide. Look what you have here. You have mole over mole. That was our third conversion factor. We said that when you have mole over mole, you are going to use a mole ratio. Well, how do you find out where the numbers are? Look at the coefficients. Okay? Look at your coefficients. So when you look at the coefficient in front of NO, you see a 6. Look at the coefficient in front of N2, you see a 5. And now moles of nitrogen monoxide has canceled out, and I'm left at moles of N2, which is exactly what I want. I don't need to go another step because I've gotten to the units that the problem asked me to get to. And so now I'm going to go ahead and put this problem into my calculator. And when I do that, I get 0.694 moles of N2, which has 3 significant figures, and if you look back at the original problem, also had 3 significant figures.